Hi, I'm Joseph Smith, Chief of Software at Gears Inc. Our robot, the R8A Phoenix, was programmed using Simulink for its graphic interface and simulation mode. All our controls are linked to a gamepad simulator, mimicking the input of the VEX controller. Additionally, virtual buttons were added inside each subsystem, in case the physical gamepad was unavailable. To switch between these two inputs, a slider switch toggles the control mode tag in the Go To block between 1 and 0. The tag's value is then sent to each subsystem. Display blocks were used both to show the motor's speeds and to monitor signals throughout the program. The first of our robot's four motion systems is the drive subsystem. It uses a joystick-driven tank drive configuration to control the robot's movements. A gain block inverts the speed of the right motor so that they will both rotate in sync. A slower speed setting was added for more precise movement. Activated by one of the gamepad buttons, it uses a custom stateflow chart to determine at which speed the robot is currently set and assign it a specified number. The slower speed setting divides the speed by 3 before sending it to the motors, while the full speed setting divides it by 1, leaving it unchanged. In addition to the speed display blocks, a field simulator block is used to show the robot's motion. Next is the arm lift subsystem. As one of our drivers was left-handed, we implemented a right-handed and left-handed control mode. Based on the input of a gamepad button, the arm control buttons are switched between the right and left sides of the gamepad. In each control mode, two buttons are used, one to raise the arm and one to lower it. We also programmed a limit switch to stop the arm from being raised too high. If it is triggered, the arm speed is temporarily reversed. A gain block then increases it to the motor's maximum speed before sending it to the arm motor. Third is our hazard removal subsystem. It consists of two claws to pick up toxic waste barrels, powered by two servo motors each. The gamepad buttons toggle their respective claw between open and closed positions. If the claw is closed, the first two gain blocks set its position at 60, inverting it for the left claw so that they will both open and close together. The position is then sent to the claw servos, after it has been inverted again by the second two gain blocks for each claw's lower servo. Our final system is the fire extinguishing subsystem. It consists of a hammer rotated by a motor, which is used to launch water, plastic balls, at the fire. This system is designed similarly to the arm lift subsystem. Like the arm, the controls for the fire extinguisher are switched to opposite sides of the gamepad if the control system is in left or right-handed mode. Because of the motor's position on the robot, the hammer motor's speed must be reversed when the final gain block increases it to maximum speed. This concludes the demonstration of our Simulink program. Thank you for watching.